Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in a lecture number 4 of circles. Okay. So, my dear friends, I hope you will enjoy this lecture. So, let's start without wasting the time. Yes, so today we are going to discuss equal chords and their distance from the center. Equal chords and their distance from the center. Okay, so first of all, here is, let's suppose we have a line AB. We have a line like this AB. Okay. And we have a point P. From point P, we can draw infinite number of line on AB. Okay. Like you can see in the figure, there is a line AL, AL1, AL2, AL3, AM. Okay, and similarly AL4, AL5 and so on. We can draw infinite number of lines from point P on line AB. Okay, so now my dear friends, out of these lines, there is just only one line which is perpendicular to AB, which is AM. And this perpendicular line, we can say that this is the shortest line. This is the shortest distance from point P and AB. From point P and AB. And in mathematics, we define this least length, we define this least distance to the distance of AB from point P. Okay, so here is the length of the perpendicular from a point to a line is the distance of the line from the point, is the distance of the line from the point. This PM line is the least distance between the point P and AB. Okay, I hope you understand these things, my dear friends. Yes, so now here is, in mathematics we know that a chord is the line segment which joins 2 points of the circumference of the circle, which joins 2 points of the circumference of the circle. In general, a circle can have infinite many chords. So the distance of the line from a point is defined as the perpendicular distance from a point to a line, like this. Here is, you can see in the figure, if we draw a distance from the line to a point O is the perpendicular line, Okay, now based on this, we have a theorem like this. So this theorem, which is theorem 10.6, states that equal chords of a circle or of a congruent circle are equidistant from the center. Okay, from the center or centers. Okay, if you talk about the congruent circles, then this will come the centers, and if we talk about just only one circle, then the center is come. Okay, so now here is, now let's suppose we have two chords AB and CD. According to this theorem, if AB is equals to CD, then the distance from the center, which is AX and OY, is equal. Then this distance is also equal. Okay, now let's prove this theorem. Okay, yes, so first of all, again we have to write the given part. Okay, so what is, so we have a circle with center at O. Okay, and AB and CD are two equal chords, Okay, that is, we can say that AB is equals to CD. What is AB is equals to CD, and OX and OY are perpendicular to AB and CD respectively. Okay, means we can say that OX is perpendicular to AB. Okay, and this OY is perpendicular to CD. Okay, and we have to prove that OX is equals to OY, means this line is equals to this line. We have to prove this. Okay, now let's start. So here is proof of this theorem. Now since we know that OX is perpendicular to AB, okay, and we know that perpendicular from the center to the chord bisect the chord. This is by the theorem, perpendicular theorem. Okay, means this perpendicular from the center to the chord bisect the chord. So we can write AX is equals to XB is equals to AB upon 2. Okay, we can write the reason as perpendicular from the center, perpendicular from the center to the chord bisect the chord. This is the theorem. We already proved this. Okay, now let's suppose this is equation number 1. Okay, and we know that also OY is perpendicular to CD. Again, this OY is what? It is the perpendicular from the center to the chord. It means dy is equals to cy. Okay, again we can write it as cy is equals to dy, which is equals to CD upon 2. Let's suppose this is equation number 2. Okay, so the reason is same. Reason is same. Perpendicular from the center to the chord bisect the chord. Okay, got it? Okay, I hope you understand this thing. Now my dear friends, here is, now given that we know that AB is equals to CD. This is, we know that this is given. Okay, so AB upon 2 is equals to CD upon 2. AB upon 2 is equals to CD upon 2. Okay, and from this, from equation 1, we can write here as AB upon 2 is what? AB upon 2 is AX and XB. Okay, so we can write AB upon 2 is AX, which is equals to, and from 1 again, from 2 again, here is, you can see CD upon 2 is what? CY. So we can write here as, we can write CD upon 2 is CY. Okay, we can write the reason from equation 1 and 2. Okay, got it? Yes. So now let's suppose this is equation number 3rd. This is equation number 3rd. Now in triangle AOX and triangle COY, means we are talking about this triangle. If we join AO and OC, then we get a triangle AOX and COY. First triangle and second triangle. In this triangle, we know that angle OXA is equals to angle OYC. Means we are talking about this angle OXA and OYC, because these two angles are what? These two angles are 90 degree. Okay, this is given. This is given, and OA is equals to OC, means this line OA is equals to OC, because these two sides are what? These two sides are radius of the circle. Okay, and AX is equals to CY. This is from equation 3rd. We can write from equation 3rd. Okay, from this above equation. So we can say that triangle. So we can say triangle AOX is congruent to triangle COY by what? By RHS rule. Here is, you can see that right angle, hypotenuse, okay, and one side. Similarly, right angle, one hypotenuse and one side. Okay, so we can say that these two triangles, triangle 1, and triangle 2 are congruent by the RHS rule. Okay, so we can write OX is equals to OY, means we can say that this side is equals to this side. Okay, by what? By CPCT, and we can say that hence proof. I hope, my dear friends, you understand these things. Okay, so this is the proof of this theorem. This is the proof of this theorem. Okay, yeah, so now let's move on. So here is, now let's see the theorem 10.7. So this theorem states that chords equidistant from the center of a circle are equal in length, means we can say that this theorem is the converse of the previous theorem, Okay, according to this theorem, here is, it is saying that chords equidistant from the center, okay, means we are talking about this OX and OY. So these chords, these distance are equal, okay, and if these distance are equal, then AB is also equals to CD. AB is also equals to CD. So here is, we have to prove that AB is equals to CD. Okay, so now let's prove this theorem. Yes, so now here is, first of all, we have to write the given part. Okay, so here is, we have a circle with center at O, okay, and AB and CD are two chords, are what? They are two chords of the circle, okay, and here is OX is the distance, from center, that is, we can say OX is perpendicular to AB, okay. Similarly, OY is the distance from the center, that is we can say that OY is perpendicular to CD. OY is perpendicular to CD, and okay, and OX is equals to OY. So these are what? These are the given parts. Okay, now we have to prove here is, so we have to prove AB is equals to CD. We have to prove that AB is equals to CD. Okay, now let's prove. Here is, we are going to start the proof of this theorem. Yes. So now in triangle, again in triangle AOX, okay, if you join AO and OD, okay, we get a triangle AOX and DOY. So this is triangle 1 and this is triangle 2. So in triangle AOX and triangle DOY. So angle OXA is equals to, means this angle OXA, this angle is equals to angle OYD, means this angle. So these two angles are what? 90 degree. Okay, so this is what? This is given, because OX is perpendicular to AB and OY is perpendicular to CD. Okay, so OA is equals to OD, means this line is equals to this line, because these two lines are the radius of the circle. Okay, and OX is equals to OY, so this is given. This is what? This is given. Okay, my dear friends, so we can say that triangle AOX is congruent to triangle DOY. By which rule? We can say that again, here is one right angle, one hypotenuse and one side. Similarly, here is one right angle, one hypotenuse and one side. So we can say that these two triangles are congruent by RHS rule. So we can write here as AX is equals to DY by what? By CPCT. By which rule? By CPCT. Now let's suppose this is equation number 1. Okay. Now here is, now you have to listen me very carefully. Okay, so here is 4 chord, 4 chord AB. Okay, so 4 chord AB, we know that OX is perpendicular to AB. Okay, and we know also that perpendicular from the center to the chord bisect the chord, so we can write here as X OX bisects AB. We can write by theorem, yes, by theorem 10.3. Okay, so this will become AB is equals to twice of AX. Let's suppose this is equation number second. Okay, now similarly 4 chord DC. Okay, here is OY is perpendicular to DC. Okay, similarly again we can say that perpendicular from the center to the chord bisect the chord, so we can write OY bisect CD. Again we can write by theorem 10.3. Okay, so we can write it as here is CD is equals to twice of dy. Let's suppose this is equation number third. Okay, so we have AB is equals to twice of AX and CD is equals to twice of dy. Okay, and from 1 we know that from 1 here is from 1 we know that AX is equals to dy. We can write AX is equals to dy. Okay, and here is AX is what? AB upon 2. AX is what? We can write AX is AB upon 2. Okay, and this is equals to dy is what? Dy is CD upon 2. We can write dy is CD upon 2. This 2 and this 2 will be cancelled. So we get AB is equals to CD. Okay, so this is the required proof. So we can write hence proof. I hope my dear friends you understand these things. Okay, now let's solve some problems. Yes, so the question number 1 is two circles of radii 5 cm and 3 cm. Okay, we have two circles which is C1 and C2 and the radius of the circle are 5 cm and 3 cm. Intersect at 2 points, okay, which is P and Q, and the distance between their center is 4 cm and we have this distance OX which is OX. So this is what? This is 4 cm. And find the length of the common chord. So we have to find what? We have to find PQ. We have to find PQ. Okay. Now, so first of all we have to write the given path. Okay. So we have here is we have circle C1 with radius 5 cm and circle C2 with radius 3 cm. Okay, intersecting these two circles, intersecting, we can write C1 and C2 intersecting at P and Q. Okay, and OP is equals to 5 cm, XP is equals to 3 cm and OX is equals to 4 cm. Okay, and we have to find here is we can write as we have to find length of common chord, Okay, so means we have to find that is length of PQ. So PQ is what? PQ is the common code, means it is the code of C1 as well as it is also the code of C2. Okay. Yes. So now let's start the solution. So here is, so this is the solution. Now my dear friends, let the point where OX intersect the PQ, means we are talking about this point. Let suppose this point is R. Okay, so we can write let the point where OX intersects PQ at R. Okay, the point where OX intersect PQ at point R. Okay, now here is, now in triangle POX, okay, means we are talking about triangle POX, means we are talking about this triangle. Okay, and triangle QOX means this triangle. Okay, in this triangle OP is equals to OQ because these are the radius of circle C1. Okay, and XP is equals to XQ. So these are the radius of circle C2. Okay, these are the radius of circle C2, and OX is equals to OX. So this is common. So we can say that triangle POX is congruent to triangle QOX by SSS rule, means triple side rule. You can say that these two triangles are what? Are congruent. So angle POX, here is, you can see angle POX means this angle is equals to angle QOX, angle QOX by CPCT. By what? By CPCT. Okay, now let's suppose this is equation number 1. This is equation number 1. Now here is also in triangle, here is, you can see in triangle POR. Now we are taking these two triangles, we are taking POR and QOR. We are taking these two triangles. So in triangle POR and triangle QOR, so here is OP is equals to OQ. Again we can write it as radius of circle C1, and angle POR is equals to angle QOR. This is, we can write, this is from equation 1. We already proved these angles. Okay, and OR is equals to OR. So this is what? This is common. So we can write triangle POR is congruent to triangle QOR by which rule? By, we can write, by side angle side rule. Okay, you can see that here is, you can see one side included angle and the another side, one side included angle and the another side. So we can say that these two triangles are congruent by which rule? By side angle side rule. Okay, so we can say angle PRO is equals to angle QRO. Okay, so this is what? By CPCT, means corresponding parts of congruent triangle. Okay, and PR is equals to RQ, means this side PR is equals to RQ. Again this is by CPCT. Now let's suppose this is equation number 2 and let's suppose this is equation number 3. Okay, I hope you get this point. Yeah, so now here is, you can see that, now here is, we know that since PQ is a line, PQ is a line, so angle PRO plus angle QRO is equals to 180 degree, because they are linear pair. They are what? Linear pair. Okay, and we know that these two angles are equal, so we can write twice of angle PRO is equals to 180 degree. So we get angle PRO is equals to 90 degree. Angle PRO is what? 90 degree. So now here is let OR is equals to X. OR is what? Let we are taking this side. OR is equals to X. Okay, understand? So here is, we know that OX is what? OX is 4 centimeter. So XR is equals to OX minus OR. It means this will become 4. OX is what? 4 minus OR is X. So this is what? 4X, 4 minus X. So means this distance. This distance is what? 4 minus X. Okay? Yes. Now in triangle OPR, here is in triangle OPR. Okay, this is what? This is right angle triangle. We already proved that these angles are 90 degree. So we can say that apply Pythagoras theorem. Pythagoras theorem. We can write OP square is equals to PR square plus OR square. We know that what is Pythagoras theorem? Hypotenuse square is equals to perpendicular square plus base square. So hypotenuse is what? 5. So 5 square is equals to perpendicular square. This is as PR square plus OR is what? OR is X square. So we get PR square is equals to, here is 5 square minus X square. It means 25 minus X square. Let's suppose this is equation number 4. Okay. Now similarly in triangle XPR, again apply Pythagoras theorem. Apply Pythagoras theorem, because this is what? This is right angle triangle. So here we can write as XP square is equals to PR square, means this XP square is equals to PR square plus XR square plus XR square. Okay, and XP is what? Hypotenuse, which is 3 square. PR is same PR square. Okay, plus XP is what? XP is, we know that 4 minus X whole square. 4 minus X whole square. So now here we can write it as, so here is PR square is, this will become 3 square means 9 minus, here is, this will become 4 minus X whole square. Yes, so now here is, this will become PR square is equals to 9 minus. Now we have to open this bracket, and this is like A minus B whole square. So here we get 4 square minus twice of 4 into X plus X square. Okay, so here we get 9 minus 4 square is what? 4 square is 16 minus 2 into 4, 8x plus x square. Okay, so this formula is like, we know that this is, we know that A minus B whole square is what? A square minus twice of AB plus B square. Okay, we know that. So now here is PR square is equals to 9. Now if we open this bracket, we have a negative sign, so all the sign in the bracket will be changed. So we get minus 16 plus 8x minus x square. Okay, So here we get, if you solve this, minus 7 plus 8x minus x square. Okay, so we can write it as minus x square plus 8x minus 7. So this is what? This is PR square. This is PR square. Okay. Now let's suppose this is equation number 5. This is equation number 5. Now from 4th and 5th we can compare, because here is the 4th equation. We have PR square is what? 25 minus x square, and here we have PR square is minus x square plus 8x minus 7. So from equation 4 and equation 5 we can write it as 25 minus x square is equals to minus 7 minus x square plus 8x. Okay, so this will become, this minus x square and this minus x square will be cancelled. So here we get 25 plus 7 is equals to 8x. Okay, so this will become, if we add this, we get 32 is equals to 8x. So here is x is equals to 32 upon 8, which is equals to 4. So now we have x is equals to 4. Okay, so now put the value of x. You can put the value of x in any of the equations. So we are putting in equation 4. You can put either in equation 4 or in equation 5. You get the same result. Okay, so we know that here is, what is fourth equation? So fourth equation is PR square is equals to 25 minus x square. So we get, so here is PR square is equals to 25 minus x square. We know that. So we get 25 minus, we have x is what? 4. So this is 4 square. So 25 minus 4 square is 16. So we get 9. Okay. So PR is what? Under root of 9. So this will be 3. So the value of PR is 3 centimeter. 3 what? 3 centimeter. Okay, so PR is what? PR is 3, and we know that PR is equals to RQ. Okay, and we know that PR is equals to RQ. It means PQ is what? PQ is twice of PR. So this will be 2 into 3, which is equals to 6 centimeter. So PQ is 6 centimeter. So the chord is what? Chord is 6 centimeter. Okay. So my dear friends, here you can see that the radius of the circle is what? 3 centimeter. Okay. So diameter will be 6 centimeter. So here you can see that we know that PQ is equals to 6 centimeter. So we can say that here is PQ is what? PQ is the diameter of the small circle. PQ is the diameter of the circle C2, and hence we can say that PQ is the common chord. PQ is the common chord. Okay, and also we can say that here we know that OR is equals to x, which is equals to 4 centimeter. Okay, and XR is equals to, we know that this is what? This is 4 minus x. It means 4 minus 4, which is equals to 0. Okay, so here is, you can see here, it means XR is 0. So we can say that this x point is coincide with R. So here we can say, since XR is equals to 0, this means point X and R are coincide. Are what? Are coincide. So we can say that PQ is the chord of circle C1 and PQ is also the diameter of circle C2. So I hope, my dear friends, you understand these things. So here we can write it as hence proof. Okay. So my dear friend, this is the proof of this theorem. Okay. Yes. So now, my dear friends, so the next question here is, if two equal chords of a circle intersect within the circle. Okay, like this, AB and CD. These are two equal chords and intersect at point X, and prove that the line segment of one chord are equal to corresponding segment of the other chord. Corresponding segment of the other chord means this AX, means we have to prove that this AX is equals to XB. Okay, and BX is equals to CX. Okay, yes. So now here is, first of all, we have to write the given part. So the given is what? Let AB and CD be the two equal chords. Be the two equal chords. Okay, which intersect. So these two chords intersect at point X. At point X. Okay, and such that AB, we have AB is equals to CD. Okay, so this is given. Now we have to prove that here is corresponding segments are equal, means AX is equals to DX and XB is equals to XC. Okay, now let's start. Yes, so here is now proof. Okay, so now we have to draw OM, means from the center we have to draw which is perpendicular to AB. Okay, and similarly ON which is perpendicular to CD. So we can write draw OM which is perpendicular to AB and ON which is perpendicular to CD. Okay, and we know that this OM bisect the line AB and this ON bisect the line CD. So we can write, so AM is equals to MB is equals to half of AB. Okay, and DN is equals to CN is equals to half of CD. Okay, so this is what by theorem 10.3. Okay, which is perpendicular draw from the center of a circle to a chord bisect the chord, means this OM bisect the AB. Okay, now as AB is equals to CD. Okay, as AB is equals to CD, so we can write half of AB is equals to half of CD. Okay, so half of AB is what? Half of AB is AM. Okay, and half of CD is what? We can write DN. So here is, we can write AM is equals to DN. Let's suppose this is equation number 1. Okay, and also MB, half of AB is also MB, so this is also MB, which is equals to NC, which is equals to NC. Let's suppose this is equation number 2. This is equation number 2. Okay, now my dear friends, in triangle OMX and triangle ONX, means we are taking triangle OMX and ONX. Here is angle OMX is equals to angle ONX is equals to 90 degree. These angles are 90 degree. Okay, and OX is equals to OX. So this is what? This is common. Okay, and here is OM is equals to ON. Okay, because we know that AB and CD are what? They are the equal chords, and equal chords are equidistant from the center. Okay. So we can write AB and CD are equal chords. What is equal chords? And equal chords are equidistance from the center. Okay, so we can say that triangle OMX is congruent to triangle ONX. By which rule? By, here is one right angle, one hypotenuse and one side. One right angle, one hypotenuse and one side, means we can say that these two triangles are congruent by RHS rule. By what? By RHS rule. So we can say, since MX is equals to NX by CPCT, corresponding parts of congruent triangle. So let's suppose this is equation number 3. Okay. Now if we add equation 1 and 3, okay, if we add this equation AM which is equals to DN, and equation 3 which is MX is equals to NX. Okay, so here we get, here add equation first and third. Here we get AM plus, okay, AM plus MX which is equals to DN plus NX. Okay, so here is, you can say that AM plus MX is what? AX plus MX is AX. Okay, which is equals to DN plus NX is what? DN plus NX is DX. Okay, understand, my dear friends? Now, my dear friends, now subtract equation 2 and equation 3. So subtract equation 2 and equation 3, means this equation 2 which is MB is equals to NC, and equation 3 which is MX is equals to NX. So we get, here is, you can see that MB minus, here is this MB minus MX is equals to CN, means this line, minus NX. So here if you see that if we subtract MX from MB, we get XB. This is equals to, if we subtract XN from CN, we get CX. Okay, so therefore we can write, AX is equals to DX. Okay, and BX is equals to CX. So we can write hence proof. So this is a required result. This is our what? Required result. So now, my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.